Hello everyone. In this lecture we are going to discuss class 8th topic chapter number 15 area practice set 15.1. So before going to the practice set 15.1 we are going to revise how the area of parallelogram can be calculated. So we have area of parallelogram. So look at once, let's have the graph paper like I am having here and try to draw the parallelogram such that we are having the name of the parallelogram, let it be a PQRS, like way I am having. Look at the parallelogram, we have PQRS such that length of the PQ we are having, look at the square grids 1, 2, 3, 4, 5, 6, 7, 8. So 8 units. And look at the length of now RQ, or we may directly evaluate now the height of the parallelogram. Suppose we are drawing the perpendicular from point S on its opposite side PQ, which is SM. So look at the height of the parallelogram. We have 1, 2, 3 and 4. So exactly 4 unit be the height of parallelogram. Keep in mind one note, while drawing the parallelogram, your segment PS is along the diagonals of your square grids. Same thing, QR is along the diagonals of the square grids, so that we have the graphical representation of parallelogram along the graph paper which look like a way. Now to evaluate the area of parallelogram, first of all try to find out number of perfect square grids covered by the parallelogram PQRS and number them like 1, 2, 3, 4, 5, 6, 7. Perfect square grids we have to calculate at start, then 8, 9, 10, 11, 12, 13, 14, then 15, 16, 17, 18, 19, 20, 21, then 22, 23, 24, 25, 26, 27, 28. So exactly we have perfect square grids, that are the 28, and plus now we have the half of square grids. Count down the half of square grids. We have 1, 2, 3, 4, then 5, 6, 7 and 8. So exactly 8 half of square grids. That means we are writing half of 8. Now half of 8 means 2 ones are 2, 2 fours are 8. So that 28 plus 4 we are getting 32. So that I am writing area of parallelogram. Here we are having 32. Now what about the unit? So 32 square units we are having. That much squares unit covers the parallelogram. Now we have to generalize the formula of parallelogram. So look at the height of the parallelogram, we have 4 units and base is 8 unit. So that once we split that 32 as a 8 into 4, 8 fours are again we are getting the same number as a 32. So generalize the formula for parallelogram, that means for finding the area of parallelogram, we are having here 8 with the base, so that I am writing base into we are having 4 with the height of the given parallelogram. So in general, for any parallelogram to evaluate area of 8, we may use the formula base into height, that much unit square, or we may write SQ stands for the square units. So that at last we are having how to evaluate the area of parallelogram by using the graphical representation of it. Now we may have the theory concept behind finding the area of parallelogram. So let's try to draw the perpendicular from point S on its opposite side, that is PQ. We have SMB the perpendicular now on PQ. So there is a formation of one of the triangle in between the parallelogram PQRS, that is the triangle PMS, which is a right angled at M. So that let's have a cut along the SM. Whatever be the triangle we are getting, let's paste it along. Let us we are having QR, I am taking N, which is right angled at M. So that the P point is along the Q now, M is along the N and S is along the R. So there is a formation of, now we have the rectangle, that is M, N, R and S. So everyone well known now, how could we evaluate the area of rectangle? Area of rectangle is given by just a length into breadth, L into B. L stands for the length of the rectangle, B stands for the breadth of the rectangle. Now look at the length of the rectangle is Mn, which is ultimately the base of parallelogram, that is PQ. So that we are writing here length of rectangle, that is equals to, we have the base of parallelogram. You may measure the length once you are having a parallelogram shaped cut of the paper. Okay, so parallelogram. And now look at the next one. Whatever be the breadth of the rectangle, that should be equals to the height of the parallelogram, that is SM, or you may say the Rn. So that I am writing next to it, we have the breadth of rectangle first, that is equals to, we have height of a parallelogram. That means from now the area of rectangle, we can replace length by the base of parallelogram and the breadth by height of the parallelogram. So that I am writing again the area of parallelogram we are getting now, as compared to the rectangle length, now we have the base of the parallelogram and into breadth of the rectangle, now we have the height of the parallelogram. So that area of the parallelogram is equals to, we have base into height, that much unit square, or you may write square units. Here SQ stands for square, keep in mind. Now look at the question number first from practice set 15.1. If base of a parallelogram is 18 cm and height is 11 cm, find its area. So that we have given, write it down firstly the given data. The quadrilateral is a parallelogram whose base we have 18 cm and height we have given, that is 11 cm. Now we able to know that area of parallelogram, that is equals to, so let's have the formula first. We have base into height. So now we have given here base is 18 cm and height is 11 cm. So 11 8s are, we have 88, carry 8. 11 1s are 11 plus 8, we are getting 19. Now 18 cm we are having and 11 cm. So centimeter into centimeter, we are getting ultimately the centimeter square, or you may have square centimeter. So at the last we are getting here area of parallelogram, that is equals to, we have 198 square centimeter, like that. Look at the question number 2 from practice set 15.1. If the area of parallelogram is 29.6 square centimeter and its base is 8 centimeter, find its height. Now we have given that, write it down firstly the given data. Area of quadrilateral, we have now the parallelogram. So area of parallelogram to be equals to, we have 29.6 square centimeter and we have given the base of parallelogram, that is 8 centimeter. We have to evaluate for height. Let us try to write height equals to the question mark. Again area is in square centimeter, base is in centimeter, so that height having the unit centimeter. So to evaluate the height of the parallelogram, we are using the same formula again. Area of parallelogram, that is equals to, we have base into height. Now try to replace the known values. Which values are known to us? Area of parallelogram is known, that is 29.6 square centimeter, that is equals to, base is known, that is 8 centimeter, into we are having a height. Now it is a linear equation in one variable where variable is nothing but the height. So to evaluate the value of height, we can't require 8. So try to shift now 8 from RHS to LHS. 8 is the multiplier. After all shifting, it will become a divisor to 29.6. So that 29.6 divided by 8, that is equals to we have a height. Now to evaluate the value of height, let's try to divide 29.6 by 8. We are getting 8 3s are 24. Remainder is 5. We have the decimal, so put the decimal in case of the question. Next 6 comes down, so it will generate the 56. Now we will know 8 7s are, we have 56. So that height of given parallelogram, we have a 3.7 that much centimeter. Try to make up a box to it. Now look at the third question from practice set 15.1. Area of a parallelogram is 83.2 square centimeter. If its height is 6.4 centimeter, find the length of its base. So that let us try to have firstly the given data. We have given at start the area of parallelogram. That is, we are having here 83.2 that much square centimeter. Next to it we have given height of the parallelogram. So that I am writing here height of parallelogram we have 6.4 centimeter. We have to evaluate length of its base, that means base equals to, I am putting the question mark. Now once area is in square centimeter, height is in centimeter, so base is in terms of we have a centimeter. Now how could we evaluate the value of or the length of the base of parallelogram? So for that again I am using the same formula, area of parallelogram to be equals to we have base into height. Now try to replace the known values. We have here known values that are area of parallelogram we have given 83.2 square centimeter, that is equals to base we have to evaluate, so keep that base as it is, into height of the parallelogram we have given 6.4. That means we have here linear equation in one variable where variable is the base. So to evaluate the value of base, try to shift now 6.4 from RHS to LHS. 6.4 is the multiplier. After all shifting, it will becomes divisor to 83.2. So that we are getting 83.2 divided by 6.4, that is equals to we have a base. Now to evaluate the value of base, look at the number in case of the numerator and denominator. We have 83.2 and 6.4 respectively. So after one place we have the decimal in case of the numerator, as well as after one place we have the decimal in case of denominator. So decimal division is little bit complicated. That's why we are converting now the decimal in terms of the integer value. That means once there is a decimal point after one place in both numerator and denominator, so try to multiply the given fraction by 10 and divide it by same number as a 10. So that now 83.2 into 10 we are getting 832.0, while 6.4 into 10 we are getting 64.0. Now 832.0 means we have 832 and 64.0 means we have a 64. That is equals to the value of base. So that should implies now I am writing base to be equals to. Now we well known 16 fours are we have a 64 and 4 twos are we have a 8, 4 0 remainder is 3, 32, 4 8s are we have a 32. So that will remain with now 208 divided by 16. Now again 4 4s are 16, 4 5s are 20, 4 2s are 8. So that base value we are getting now 52 divided by 4. Now we able to know 4 1s are 4, 4 1s are 4 and 4 3s are 12. That means 13 4s are we have a 52. That means the value of base now we are getting a 13 of a parallelogram in terms of the centimeter and the area of parallelogram in terms of square centimeter. So length of the base of a parallelogram in terms of we have a centimeter. So that the length base we are having 13 centimeter. So here we have our practice set 15.1. Thank you.